Hi Paul, can you tell me about Avio's efficient water pumps?
Sure. What I've got to show you today is this water pump system, which includes a controller and a water pump. This particular one is for a bore pump or a well pump. The way that one of these pumps is installed, if you have a look on the screen over here, this is a drilling rig, and this particular installation was in Victoria, in Hillsville, and the drill is drilling a hole down into the ground, a long way down. So a geologist will work out how deep to drill, and in this case they drilled down 130 metres into the ground. Then they put these sleeves in here, which are basically about this diameter, and they drop them into the ground to create the well. And when they got down to 130 metres, the water rushed back up the well, up to about 30 metres from below the surface. That's just the way the terrain works under the land that you can't really see. And then we have to work out how to get the water out of that well and into the dams. So in this particular case, I'll take you to the next photo. We installed a solar array with 8 solar panels. Now the clever thing about this water pumping system is we don't have to connect it to the grid, which means we don't have to pay for electricity and we don't have to pay for the really long cable to go back to the grid. In fact, the cost to get a cable to this point from the grid was more than the cost of the entire pump installation, including the solar panels. So you can see how much more efficient it is to install a solar powered pump rather than a grid connected pump. I should take you to the next photo. This is the terrain that we're working in. This is the Yarra Valley. If you have a look up the top here, there's actually a tank right up here. And the water pump here pumps water all the way up the top of that hill. In fact, the capacity of this water pump is such that it can push water up a quarter of a kilometre up. So it's a very powerful pump. A lot of pumps can't push water that high, but in this case we can go a quarter of a kilometre up. So because the water was down 30 metres from the ground, we were able to push 30 metres up and then another 220 metres directly up. In this case we had a tank on the top of the hill here which was about maybe 80 metres higher than the ground here, and then from there we went to another tank another 80 metres up. So we almost used the full capacity of the pump to get water from well under the ground here all the way up to the top of the hill for no running cost at all. The farmer who installed it, you'll see a photo of him soon, says the cows just love the water because it's crystal clear, it's from under the ground, whereas before that they were drinking this muddy dam water which wasn't quite as tasty. And before that the cows had to walk all the way from their corners of the paddocks to get water, and then they would eat a lot of grass around here and not as much grass in the corners. So by having fresh water available in a tank, he was able to reticulate that water all around the farm to their troughs and give them fresh water every day of the year. We'll just take you to another photo. Another clever thing about this pump is that you can actually see what happened. So you can log on through your smart device. In this case it's a Samsung Galaxy, I believe, and it tells you how much power is coming from the panels, what the voltage is of the solar array, how fast the motor is turning, and the temperature of the controller. You see that it's on at the moment and pumping water. So we can see how much water was shifted per day. In this case the system was designed to pump about 5,000 litres of water per day on the worst day of the year, or the driest day of the year, which in this case the driest part of the year is actually around April because of the way winter and spring and autumn work in this area. I'll just take you through to see some other photos as well. Got something else here for you to see. Have a look here. So there's the whole installation. There's the farmer. He's quite happy with himself because he's now got free water for many, many years to come. We expect that the system won't need to be maintained for at least 10 years, probably even 20 years depending on how often the motor runs. You can see here it's got a concrete pad which is holding the top of the bore which goes under the ground, and there's a bit of plumbing that the farmer put together to get the water up to the top of the hill, which is just up here. This is the pipe that went underground. We use this piping system called FlexiBore. FlexiBore it's almost like a fire hose, and when you push water into it, it goes hard, like you would expect. But the clever thing about a FlexiBore is it's much easier to install. Many farmers in the past have used bore pumps which run off mains power, but they've also got a solid pipe, which is very hard to actually get in and out of the ground because it's got a big curve radius on it and you've got to pull it right out. Whereas because this is a soft pipe, you can roll it up and put it in, pull it out. You can see beside it we've got 2 cables. we've got a cable here. I've actually got 3 cables. We've got a power cable here, and we've got a water sensor, and we've got another sensor there as well. So we want to know how deep the well is and how much water is there, and if the well runs dry, we want to turn the pump off so that we don't wreck the motor. And here's the happy farmer enjoying the water coming out. So this photo was taken at about 3 o'clock in the afternoon. So there was almost no sun left. The sun had almost disappeared over the hill, and it was the middle of winter. I think it was almost winter solstice. So the worst sunny day of the year, with clouds and the sun almost gone behind the mountain, and we're still putting water out. And we're putting out about a litre every 3 seconds there on the worst day of the year. There's a whole system installed, so there's the panels up here. Up here you've got a little thing called a sun sensor, and that just detects when it should start pumping. We don't want to really pump when there's no light or just morning light, because it's just not enough energy to move water. So we set this at a threshold, say at about 30%. So once it gets about 30% of the light on the panels, then the pump turns on, instead of it trying to start when there's just no light in the sky. I've shown you that one before. And here's the preparation. So this is a stainless steel pipe that was concreted into the ground, and that's the actual bore pipe there that the drilling contractor installed earlier. And that's it. So basically what we do is we control the water pump using this controller here. It's got some little information on here. There's a pump sensor for the well going dry. There's a pressure switch sensor as well. So if the top of the hill, the tank gets full, the switch goes up, and the pressure builds up down the bottom, and it switches the pump off until that float switch goes down the top again, and then it can refill the tank again. So there's a few different sensors we can put into it. We can also change the speed of the pump. We can change the speed of the pump using the software, or we can do it manually inside the pump itself. This is a pump. There are many pumps in the range. This particular one, I think, can pump about 50 metres head. The one that we installed on this project can pump 250 metres head. So there's a whole combination of different impellers and motors and voltages and solar arrays that we can use for different types of applications. So one might have a shallow bore with a small water requirement. One might have a really, really deep bore with a high water requirement. Need a lot more solar panels and a bigger pump. So what we use is a program called, I can't show it to you right now, but it's a program which is written by Lorentz, who's the pump manufacturer, and we type in the location, the amount of water you want per day, and the day of the year that you want that amount of water. So it might be a summertime watering requirement, like for a vineyard, or it might be a wintertime watering requirement, like say for cattle. And we use that information to choose the size of the pump, and the location and the postcode to work out how much sunshine is falling on that land, to work out the size of the solar array to deliver that much water. So it's quite a calculated design, and we typically over-design the solar array so we get more water than we really need, because we can just turn it off when we don't need it, because the water's free and the sunshine's free. So the best way to move water is using a Lorentz water pump and controller. Additionally, this whole system can work for swimming pools, but I'll tell you about that in another chapter.